What if robots didn't have just one brain, but 100? And what if every muscle, every joint, every finger in a robot could think on its own? That's exactly what a new company called Physical Intelligence has made. They've created a robot unlike anything we've seen before. It's called Pi 0.5, and instead of a central brain, this robot spreads its intelligence throughout its body. Each part is smart. Each part reacts. It's like giving a robot reflexes and also common sense. Let's break down why this robot is being called one of the most exciting advances in AI and robotics to date. A robot with muscles that can think. Traditional robots use a single central computer to control everything. Move an arm, the signal travels from the hand all the way to the brain and back. It's slow, it's clumsy, and it doesn't handle complex things well. Pi 0.5 changes everything. Instead of one brain, it has dozens of tiny processors called Pi nodes in its arms, hands, and even soft silicone fingers. Each of these nodes has its own sensor, its own neural network, and its own motor. In simple words, this means that the robot doesn't need to wait for a command from its brain. It can make smart, small decisions on the spot. It's like the microbots in Big Hero 6, except think of all these in a single body. For example, if it's holding a cup and feels it start to slip, the fingers react instantly, just like your reflexes. This kind of local, fast decision-making makes Pi 0.5 much more energy efficient, flexible, and durable in such environments. Less power, smarter movements. The team behind Pi 0.5 didn't just want fast reflexes, they wanted intelligent behavior. So they designed this two-layer brain system. Layer 1, each Pi node uses reinforcement learning to adjust its movements in normal time. It remembers what worked and what didn't. The result? It gets better at holding, pushing, or moving objects without needing new code. Layer 2. On top of the reflexes, the robot has a brain that can see and understand. It uses a vision damage model, basically an AI that can understand instructions, pictures, and even voice commands. This higher-level brain tells the body what to do, while the mini-brains handle the how. This allows Pi 0.5 to perform difficult tasks, like picking up fragile items, opening doors, or even helping in household chores, all with surprising agility. Tests show that this dual-layer system decreases energy use by 25% and improves performance accuracy by over 30%. That's a big win for robots meant to live in hospitals or homes. Learning like a human. What makes this robot even more unique is how it learns. Most robots are trained in simple, clean labs. Everything is perfect, but life isn't like that. So Physical Intelligence took a different route. They sent their robots into real homes, kitchens, bedrooms, bathrooms, and recorded hundreds of hours of real interaction. They captured what it looks like when robots succeed, fail, struggle, and adapt. They also added footage from other robot arms, home videos, and also internet content. The robot was trained on everything from handling plates to recognizing a pet. Some clips even had humans talking the robot through tasks, like grab the blue mug carefully or don't spill the water. By combining all of this, language, touch, vision, and motor data, Pi 0.5 has developed a kind of common sense. It knows, for example, that you need to hold a glass gently, but you can press a sponge hard. It doesn't just follow commands. It also understands context. Flexible design, endless possibilities. Another powerful feature, it's hardware. This brain system can run on different types of robots, small or large, cheap or advanced. You could have a cleaning robot, a cooking robot, or even a robotic assistant for elderly care, using the same Pi 0.5 structure of the brain. And because the intelligence is spread out, the system is safer and much more reliable. If one mini-brain fails, the others keep working. That's a big deal for robots that need to operate in unpredictable spaces. This flexible design also means these robots could become much cheaper and easier to build over time, making advanced robotics more accessible. Why it matters? This is more than just a cool robot. It's a shift in how we think about artificial intelligence. By giving robots the ability to think, feel, and adapt locally, we move closer to robots that can live in our world, not just in labs or factories. Imagine a robot that can wash dishes, help someone out of bed, or play with a child without needing supervision or exact instructions. That's the future Pi 0.5 is pointing toward. And because it uses less energy and needs less coding to improve, it's a much more sustainable and scalable solution than other robots. What people are saying. The buzz online is real. Many are calling this the most human-like robot system they've seen, not because it looks like a person, but because it learns, adapts, and reacts like one. Some compare it to how our own nervous system works. Each muscle responds before the brain even knows what's happening. That kind of decentralization makes us safer, faster, and more efficient. And now, robots can do the same. Of course, there are concerns. People wonder, will AI robots replace human workers? Others ask about safety. Can a robot with hundreds of brains be updated or controlled easily? But most agree, this is a major move forward. What's so exciting about Pi 0.5 isn't just its intelligence, it's the philosophy behind it. Rather than build a big brain and hope for the best, the creators made every part of the robot smart. They respected how the human body works and used it as a model. The result is a robot that feels more responsive, more alive, and more ready for the world. This is the kind of breakthrough that makes you think, if robots can now think with their hands, feel with their fingers, and learn from their mistakes, what's next? And more importantly, how long before one of these lives in your home? What do you think? Let me know in the comments below, and don't forget to subscribe for more info on AI, robots, and new technology.